Imagine an industrial heating system, custom engineered here in Bangalore from India for treating the auto components of Tesla automobiles. And we have just done that. Hello everyone, I am Kritik from RNS Engineering Works. With over 3 decades of team expertise, having served close to 100 clients in just 5 years of operations, I would like to proudly introduce our company as one of the most preferred customized industrial ovens and heating systems manufacturers in India. Today, I would like to share a significant milestone in our journey with you all. We have completed a major export project which is supplying 3 cutting-edge industrial ovens to SMR Automotive Australia through SMR Automotive Chennai. And these ovens are also called as clean room ovens for this project. And the purpose of these ovens is to help in curing the automotive components of Tesla automobiles. And the best part is that we have complied with one of the most stringent quality standards for Type 1 ovens, which is nothing but the Australian standards that are similar to the NFP as well. That is the gist of it. Let's have a walkthrough of the oven, try to understand its key components and why they are so important. Here we go. This is the hot air oven, which we also call as clean room ovens for this project, and that's the electrical panel supporting right there. So whatever you witness here, the entire design and engineering is completely based on calculations, depending upon factors such as volume required, nature of the product, temperature, and the heating or cooling cycle required. The fundamental purpose of these ovens is to cure the automotive components for a temperature ranging up to 200 degrees Celsius for X number of minutes. So these heating cycles and cooling cycles are completely adjustable with our PLC based electrical panel. And the product can vary from nature to nature as long as it complies with the safety requirements and the temperature requirements. Coming to the principle of this oven uses a hot air oven principle, which means that the temperature is gradually increased and maintained at a level by constantly circulating heated air within the oven. To better understand this procedure, let's visit each part carefully. Alright, let's start with the door. The entire body of the oven is made with SS304 and let's open it. As you can see, there's a tight lock system and it's also equipped with a safety lock on the top. And there's a silicone rubber lining. This is for ensuring leak-proof functioning of the oven. And the security system door is also ensured for safe operations so that the door doesn't open anytime during the operation. Getting inside the oven, this is how it looks. This is the inner chamber, and products that are to be heated are to be placed on a trolley and pushed inside. Like I mentioned, the purpose of the oven is to cure auto components. The component we have right now is plastic light guides of Tesla automobiles. To rise the temperature within the oven, we have the heater bank, which is located on the top of the oven. It lies on the roof. So we have 24 tubular heaters and they gradually rise in temperature and heat the air around the vicinity. To circulate this heated air and generate temperature, we have a recirculation fan located on the top left. The impeller located on the top left, what it does is it starts sucking air from the fresh air inlet located on the top right. The air passes through the heated chamber and the heated air is then circulated down the oven through the baffle, and that passes through the louvers and circulates within the oven as you see in the inner chamber. The fresh air inlet located on the top right is provided for fresh air to enter into the oven and get heated up through the heated chamber. As of now, it's kept at 10% opening to avoid vacuum buildup and temperature overshooting. As you can see, the fresh air inlet is over here and it's equipped with a HEPA filter which removes close to 99.9% of dust particles. This allows us to maintain a clean room required for curing this component. Also, the fresh air inlet is pneumatically operated through the PLC based control panel, and this allows us to maintain the opening percentage which varies product to product. So far we've covered how the fresh air enters from the fresh air inlet, gets heated up through the heated chamber, and then how the impeller sucks the air and pushes down through the baffle. So the baffle is nothing but the space between the louvers and the inner chamber, which we also call as the inner sheath. there are louvers present on both side walls of the oven, and these are adjustable as well. So this helps in maintaining optimal airflow as and when required, and also to maintain the temperature. While the louvers on the left end allow for air to flow within the inner chamber and heat the component, the louvers on the right side wall help in suction, and the air passes through the baffle again and goes to the heated chamber. So this air circulation is constantly maintained for the set duration, so that the temperature within the inner chamber reaches the set value and ensures optimal curing of the products. Now, how do we measure if the oven temperature in every corner of the inner chamber is the same? So this is where RTD sensors come into play. We have 10 of them, 5 located on each side. So these accurately measure the temperature throughout the heating cycle, throughout the duration, and they display it as the data on the HMI. To ensure a safe working environment within the oven, we've provided a ventilation system. So it consists of a vent pipe and an exhaust fan. So the main function of this vent pipe is to expel any fumes that is from the product during the curing process. Like I mentioned, the oven temperature rises up to 200 degrees Celsius, and sometimes even more than that in some cases. So you might have wondered if or if not the heat gets transmitted outside the oven. So this is where insulation comes into play. So we have provided a thick ceramic wool blanket between the inner sheath and the outer sheath, so that the temperature doesn't get transmitted from inside of the oven to the atmosphere. And the insulation is provided on all the 6 sides of the oven. Another critical safety feature in a type 1 oven is the explosion vent. Let me tell you why it's so important. In a rare event of an explosion due to flammable particles or zero ventilation, this explosion vent completely opens up and relieves all the inner pressure to the atmosphere. Now we have covered almost everything about the heating cycle, post which comes the cooling cycle, right? So to make sure the product cools down in a specified amount of time, we have installed a suction blower which expels all the heat from the oven outside into the atmosphere, and this happens over a duration that is mentioned in the PLC. Well, coming to the rear side of the oven, here is a suction blower. It expels all the heat from the inner chamber to the atmosphere, and it's equipped with a motor and a impeller. This is used to enable suction of the air and passing it through the duct. As you can see, this suction blower is again automatically operated through pneumatics, and this only operates during the cooling cycle. Briefing about the electrical panel, we have a human machine interface. This is where we operate the oven in terms of setting values and setting temperature values, controlling the heating cycle and extracting data. To ensure optimal power usage for the heaters, we have a thyristor installed, and also to control the recirculation speed, we have a VFD drive which is connected to the recirculation mode. So yeah, that's about it. This is the electrical panel, and we've summed up the mechanical aspect as well. I hope you've got a fair understanding of how an industrial oven like this will work. It's a significant milestone for us at RNS Engineering Works, having supplied 3 of these ovens to SMR Automotive Australia, wherein Tesla's components are being heated. Do contact us for any requirement related to customized industrial ovens and heating systems. We are always at your service. This is Kritik signing off. See you in the next one.